All right, here in section 3.3 and 3.4, we're going to discuss logarithmic functions, exponential functions, and how to convert between the two, and just how to manipulate different expressions that involve either exponents or logarithms. And most of this is going to be done without a calculator. So just as a heads up, make sure that you are understanding how to do the things that we're talking about without the use of your calculator. Okay, so the first thing that we want to do is we want to take exponential expressions and write them as logarithmic expressions. And so I've got a fancy little acronym to help you here, and I think it'll help you understand how to do this. And so just as a reminder from the previous page, if I have log base b of y is equal to x, then what this means is that b to the x is equal to y. And so what we're going to be doing here in example 1 is going from b to the x equals y to log base b of y is equal to x. And so if I want to take 2 to the 5th is equal to 32 and transform that into logarithmic notation, probably the first place I need to start is by writing the word log. That's a really good start, is to put log. Now, the first number that you're going to put down is the base, and you're going to write it as a little subscript lower than that g. And so the base in this expression is 2. And so I'm going to start with log base 2. And so the first thing I'm going to write down is the base. The next thing I'm going to write down is the answer. And so of those 3 numbers in letter A, which of them would you say is the answer? Well, 32 looks like it's the answer because it comes after the equal sign. So 32 is what I'm going to write next, and that's not going to be a subscript. It's going to be just regular font. And so the next thing that's going to come is the answer. And then that is going to equal to the exponent. And so BAE is a nice little acronym to remember the order in which these numbers come. And so this is going to equal to 5. Okay, letter B, same thing. I'm going to start with the word log. I'm going to start by writing the base, which is 0.5 in this case. That is going to be, the next thing after that will be the answer, so 0.125, and that's going to equal to the exponent, which in this case is 3. So base, answer, exponent, that's the order that the numbers go in. Okay, here in example 2, we're going to be going the other direction, and we're going to use what some teachers call the log loop. And so here's how we perform the log loop to write things out of logarithmic form and into exponential form. We start at the base, which if you look in letter A, there is no base written, but there is a base. And so what's the base of the natural log? The base of the natural log is e. And so I'm just going to draw a little e in there to indicate that, and then start my log loop. So the loop starts at the base, it loops around to the exponent, and then you just read this from right to left. And so this will be e to the 5th is approximately 148.41. And these expressions, just so that it's clear, these expressions are equivalent, they're just written in different formats. It started as a logarithmic expression, and I wrote it here as an exponential expression. Okay, letter B, this is a base 1/2 logarithm. Log base 1/2 of 32 is equal to -5. And so I'm going to start by working my way from the base to the exponent. So 1/2 to the -5th is equal to 32. And so that's what that will be in exponential notation. Now, here's one just pointer. Make sure that what you write is a true statement. So, for example, if I have log base 2 of 8 is equal to 3, if you write 3 to the 2nd is equal to 8, that's not a true statement. If you write 8 to the 3rd is equal to 2, that's not a true statement. Okay, make sure that you are actually writing something that is true whenever you do this, which would be 2 to the 3rd is equal to 8, because I loop to the exponent and then I read it from right to left. Okay, letter D, log base 8 of the square root of 2. So again, I would suggest putting this equal to x and then rewriting it as 8 to the x is equal to the square root of 2. Now, when we talk about square roots, there is an algebra trick, or not a trick, but a property that we use, and here is the property, that when we have a to the m over n, this is the same thing as the nth root of a to the m power. And so for this square root, whenever we have the square root of x, let's say, that is always equal to x to the 1/2 power. And so when I rewrite this in base 2, I know that 8 is 2 to the 3rd power, since 2 times 2 times 2 is equal to 8. And so that part can be rewritten as 2 to the 3x, and that's going to equal to 2 to the 1/2 power, because square root of 2 is the same as 2 to the 1/2. Okay, so that's going to give me 3x is equal to 1/2, and if I divide both sides by 3, that's going to give me x is equal to 1 divided by 6. And so 1 divided by 6 is going to be the answer there. If you're struggling there with the fractions, notice that dividing by 3 is the same as multiplying by 1/3, and then 1/2 times 1/3, you just multiply across, and so that's how I got 1/6. Okay, for log base 36 of 6, if I set this equal to x, then this is going to be 36 raised to the x is equal to 6. The common base here is going to be 6, because 6 to the 2nd is 36, and this is 6 to the 1 over here, and so therefore this is going to say 2x is equal to 1, and divide both sides by 2 in order to get 1/2. And that should make sense that the answer there is 1/2, because if you think about it, this question is asking 36 to the what power is 6, and since 6 is the square root of 36, then it means that I would have to raise 36 to the 1/2 power, because that would be taking the square root in order to get 6. Now, letter F does not have a number to indicate the base, and so remember from the previous notes that means that this is base 10, and so this is going to say 10 to the x is equal to 0.01, which is really just another way of saying 1 over 100, which is really just another way of saying 1 over 10 squared, which is really just another way of saying 10 to the -2 power, so that I can move that up to the numerator and actually have like bases. And so now the bases are the same, therefore I'm going to set the exponents equal to each other, and I get that x is equal to -2, which means that that expression is equal to -2. Okay, a couple of more examples here just to give us a little bit more practice. So again, here on letter G, I'm going to write 1 over 64 to the x is equal to 32. Now that 1 over 64, the 64 is in the denominator. I want it to be in the numerator, which means I'm going to have a negative go on my exponent. And I also need to think about what the like base needs to be. And so the like base here is going to be 2, because I know that 32 is 2 to the 5th, and 2 to the 6th is 64. So I'm just going to kind of go slow here and rewrite 64 as 2 to the 6th. And then this can become 2 to the -6 raised to the x, which is equal to 2 to the 5th. And then that really just becomes 2 to the -6x is equal to 2 to the 5th. Because whenever I have a power to a power, what I end up doing is I multiply those powers together. And so now I'm ready to drop the bases. So -6x is equal to 5. And so therefore x is equal to -5 divided by 6. Okay, letter H, we've got something kind of similar here. So 729 raised to the x is equal to 1 over 81. The like base here is going to be either 3 or 9. It doesn't really matter which one of those that you choose, but 9 to the 3rd is 729, so I could rewrite this side as 9 to the 3x, and that's going to equal to 1 over 9 squared, which is really the same thing if I move that to the numerator as 9 to the -2 power, which means that 3x is going to equal to -2, and so therefore x is going to equal to -2/3. Okay, and then finally, one more example here. In letter I, I've got log base a of the cube root of a to the fourth, and so that's going to bring in our exponential rule that we talked about earlier, converting between exponential and radical notation. And so I'm just going to set this equal to x like I normally would, and write a to the x is equal to a to the 4/3 power, since the exponent is the numerator and the index of the root becomes the denominator. So that becomes a to the 4/3. And so now the bases are the same. I'm ready to just drop the bases. And so x is equal to 4/3.